between the two surfaces. So suppose we have two surfaces, let's say block A and block B. So say this is block A and this is block B. Now the value of friction force which is acting on these two blocks will be proportional to the normal force acting on these two blocks. So since these two blocks are in contact, the normal force acting on block A will be perpendicular to the surface, that is in this direction, and the value of friction force Fr will be proportional to normal force, and we can write that Fr is equal to mu n, where mu is called coefficient of friction. Similarly, on block B, the normal force will be the same, that is n, and the friction force Fr will be mu n. Now the value of mu is dependent on the nature of surface of contact. So between two different surfaces, the value of mu will change. Now this value of friction force, that is mu n, is the maximum value or limiting friction which can act between the two surfaces. Now when the two surfaces in contact do not move relative to each other, then the force of friction between them will lie between 0 and the limiting friction. So for example, suppose we have two blocks, block A and block B, and the value of coefficient of friction for the surface in contact is mu, and the value of normal force acting on block A and block B is n. So here the limiting friction Fr will be mu n. So now suppose a force F is applied to block A. So the friction force between block A and block B will oppose the relative motion. So on block A, a force F dash R will act, the friction force. Now the value of F dash R will lie between 0 and Fr, where Fr is mu n, and since the block is not moving, the value of F dash R will be equal to the applied force F. So from the free body diagram we can see that the forces acting on block A are force F, which is external force which is being applied on block A, and the friction force F dash R. And since the block A is at rest, it is not moving, so F dash R must be equal to force F. So in this case, the coefficient of friction mu is also called mu s, that is static coefficient of friction. And the term static here indicates that there is no relative motion between the surfaces, that is surfaces in contact are at rest. Now let's see what is kinetic friction. If there is some relative motion between two surfaces in contact, the friction force which is acting between these two surfaces is called kinetic friction, and its value is equal to mu k into n, where mu k is the coefficient of kinetic friction. So to understand this, let's take the same example. So suppose we have block A and block B, and a force F is acting on block A, and because of this force the block A starts moving in the right hand direction. So the friction force which is acting on block A will be in the left hand direction. So the forces acting on block A are F, which is external force, and friction force FR. Now since in this case the block A is moving with respect to block B, we call the friction force which is acting on block A kinetic friction, and its value is equal to